Hello there everyone and welcome back to Kerbal Space Program Flyer's Ed. We are here once again with Mr. Fisher, our instructor, and we're ready to roll.
Yes, we are indeed.
And we are just approaching the SOI change for our first Kerbal ship.
Yep. So we're going to run through the next 60 some odd seconds on 1x time. Let's go out to the map view.
Okay, let's have a look at things. There's a lot of lines going a lot of different places right now.
Oh, you've seen nothing. So, we already know that once you get to orbit, you're halfway to anywhere.
Yeah,
we already know that, right?
Mm-hmm.
Why do you suppose that is?
Because gravity wells are expensive to get out of. And the bigger the planet, the more expensive the gravity well.
Especially when you're compounding onto that gravity well atmospheric drag.
Right. They NASA. I read it somewhere. It was called the tyranny of the rocket equation.
Yep. That's a very real thing. We are coming in from at atmospheric interface. That's fine.
Mm-hmm.
At atmospheric interface, we are going to be traveling at near-mooner velocities. That is a shorthand term for just saying we're basically coming straight down from the moon and picking up speed along the way. Because we had an orbital speed around Kerbin, which was the orbital speed of the moon.
Mm-hmm.
We subtracted from that slightly in order to eject from the moon. And it results in this apoapse that's probably a few thousand kilometers in altitude below the altitude of the moon itself.
That's be about right.
Okay. So we're coming in at near-mooner velocities. Now, as we know from playing this game and from your other series, the delta V necessary to get to mooner orbit is not that much different from the delta V necessary to get over to Eve, for example.
That's right. It's a few seconds more burn, but it's not even a quarter of the total burn time.
Right. It's on the order of 200 to 500 meters per second difference in delta V, depending on what your transfer window was, depending on your engine efficiency and that kind of thing. But, the delta V doesn't depend on your engine efficiency. What that delta V difference means as far as the difference in your burn time is determined by your engine efficiency. Now, our heat shield, when it was designed by the developer of the Deadly Reentry mod, his baseline was looking at the Apollo capsule. And it was designed to operate at lunar reentry speeds. The original Apollo program was not designed to do a powered braking orbit into low Earth orbit. It was designed to go straight from the moon down to the Pacific Ocean in one fell swoop. And because of the energies involved and the size of the craft and the size of the Earth, and the fact that you were actually carrying lives on board that you wanted to save, those were some pretty important calculations to work with.
Right.
Obviously, for purposes of this game, there's been some license taken with the math. It's not a scale model of the human Earth system. So there's some departures from what actually happened, not the least of those departures being the actual aerodynamics model itself.
Which is soupy, as I've heard it called.
Yes. I will repeatedly refer to it as electronic mayonnaise, because as far as I'm concerned, that's what it is. Let's pull down our resource panel right now.
All right. And there's our ablative shield right there.
Yep. We do not have a lot of fuel remaining. We have about 136 meters per second available,
Yep.
just under 30 units of fuel. And for standard LFO, liquid fuel, liquid oxidizer engines, I think it's more effective to express shorthand fuel amounts in terms of your liquid fuel units and not your oxidizer units.
Makes sense.
It's the less optimistic of the two numbers, as we see, and as long as they're in proportion, 29.83 is the exact same delta V as 36.46. Anyways.
Yep. That makes sense.
We also have 1,000 units of ablative shielding. Now let's get out of the map view for a second and look at the craft.
Okay.
Okay.
So the ablative
Where
shield,
is our... Yep.
It's tucked in right there. That's it right there.
Okay. Now, what happens in our current flight configuration if we just let it go?
If we just fly... If we don't... You mean if we don't eject the lower part of the ship?
That was the first half of the trick question. Very good. But yes.
Yeah. Well, all this burns up and we pray that it doesn't explode in such a way that the thing starts tumbling and destroys the rest of the ship. I've had experience with this.
What makes you think it'll tumble?
I've had tumble occur when some of the exterior components blow off. If this one battery blows off and this other one doesn't, I've had tumble get generated by that. Especially if you don't come into the atmosphere absolutely perfectly retrograde.
Okay. You might have meant something else, which is not as well based in reality as what you just said. Mm-hmm. With things like batteries or certain other types of greebly items, you do have to worry about oscillations induced by asymmetric drag, or not even asymmetric drag, but asymmetrically distributed mass reacting to drag. Because drag imposed from slowing down, as far as physics are concerned, is the same as engine thrust applied in a direction, except you can only have engine thrust come out of the bell housing.
Okay, interesting.
It is important to know that in Kerbal Space Program there is such a thing as a physics-less part. Anyone who modifies their own parts, you go into the .cfg, and there's a lot of variables there that I do not recommend playing with if you don't know what they do, or at the very least maintain backups. But one of the variables, I don't have it on my screen here, physics significance as one word, and there's a 0, a 1, and I think the parse interpreter will accommodate a 2 or a 3, but 2s and 3s aren't assigned values in the current version of the game. For whatever reason, in an early version of Alpha, there were problems that resulted in things not... I think it was with landing gear. And the only way to solve it at the time was to remove physics-based calculations from a certain class of parts. Now those class of parts include stock landing gear and many modded types of landing gear. I've seen one example of a modded landing gear that is physics significant, but that's the vast minority. Also physics-less are things like ladders, fuel lines, struts, yes, and a lot of other things. You happen to mention batteries, and I don't know if solar panels are physics-less. I don't know if landing gear are physics-less. I can look it up. But I think batteries are actually physics significant. So you are correct that it's not the explosion itself that we're worried about. It's what the explosion does to our drag scenario and to our mass distribution scenario.
Okay.
However, backtracking through what you said, if we retrograde in properly, I wouldn't suggest time. Well, yeah, we've got an alarm up, so it's not that big of a deal. Let's go. Go ahead.
Does this guy need to make any adjustments before we do this re-entry, or...
That is a good question.
Yeah. Because I vaguely recall that, well, what is now a... Is that an impact now? Yep, that's an impact periapsis. I vaguely recall that that is not a survivable re-entry from the moon in this mod.
You think it's the mod that results in impact trajectories being not survivable?
I've never actually determined if you can survive a re-entry like this in stock with no deadly re-entry.
Probably. It depends on if you had enough parachutes.
Right. One single Mark 16 XL parachute. Maybe not.
I wouldn't bet my own paycheck, but if you want to play with yours, let's go.
Well, if it's not survivable with that, it's certainly not going to be survivable with deadly re-entry, is it?
Let's look at the flight engineer. We're looking at a periapse that for some reason is oscillating just under 2 kilometer depth in comparison to sea level.
That would be physics going on, or the floating point weirdness going on there, because this shouldn't be changing under these circumstances, should it?
That's correct. But let's call it a little bit less than, well, now it's a little bit more, for crying out loud. 2 kilometer periapse.
Yeah.
Negative periapse.
Yeah. Okay.
At what time can we expect an impact?
Less than 4 hours and 30 minutes.
Tell me how you arrived at that answer.
Because it's actually it might be quite close to 4 hours and 30 minutes, because we're going to get slowed down by atmospheric drag, right?
That's true.
But our impact is also below the surface, so the surface is going to hit us before we hit the periapsis.
Very good.
In fact, depending on exactly where we wind up landing, it could hit us quite a bit before the periapsis.
If we're happen to be headed towards a high altitude mountain range, sure.
Yeah.
Let's go to the map view again and look at trajectories.
Mm-hmm. Trajectories. Oh yeah, there it is.
It doesn't like our... No.
It's there. I'm pretty sure it's on.
No,
yeah, it's on.
That's the orbit of Kerbal Station 1 that you were pointing to.
Was it?
The reason it's not showing us a path...
is because there isn't one.
Is because there isn't one. Now, I am mildly concerned that it's not showing us a small perturbation for once we hit atmosphere. But because it'll be so small at this scale, it's not really something that I'm exceedingly worried about.
Yeah, I think it's just not visible because it's so going to be basically right into the planet. It's probably making the math a little sad.
Yeah, this is less of a planet re-entry and more of a pincushion maneuver.
Mm-hmm.
So that is odd. Now it's up to 2.5.
Well, that's
at any rate.
Yeah, everything's sort of a little shaky right now, isn't it?
Now, at what point can we approximately anticipate atmospheric interface?
Let's see. It would be right about just as we pass the orbit of Kerbal Station 1. If we just look at it from here. Hey, there it is. Is that little red line there?
Yeah, that's what I was talking about. Yeah,
it's there.
If it was a snake, it would have jumped out and bit me. All right.
Yeah.
So
we can say right about there then, because that's where the trajectories program starts recalculating it.
Sure. Let's back off 2 or 3 oomphes from that.
So.
Much closer. Yeah, about at the orbit
there,
or a little bit there, or maybe a little bit closer to the surface.
Okay. We're setting a maneuver.
Sure.
Okay.
We have a little bit more than half an hour to play with this before we have to worry about the Mark II's SOI change.
Mm-hmm.
This tells us that we have a solid 4 hours and something minutes at least until atmospheric interface.
Right. Okay.
Let's play with some of the inputs there. We have 136 meters per second delta V available. Let's negative 136.
All right, yeah, that makes sense. Just negative 136. All of our fuel, and so it does nothing for our proposed periapsis. Drops our apoapsis from 10 million to 3 million. Or, sorry, 4 million.
So this does tell us that burning retro by 136 meters per second will rather substantially reduce our orbital energy. That's why our apoaps would drop by this calculation.
Right.
But it doesn't drop either sufficiently or in the correct way or soon enough to prevent the Kerbal X go boom.
Right. So that's not going to help us save the Kerbal X.
Not by itself, no.
No.
But we see by the Nav Ball, however, that we're looking at a burn magnitude of 136 point some odd.
Right.
No matter what we do with prograde, normal, and radial, as long as we keep our absolute burn magnitude of approximately 136 or less, it's a burn that we can hope to accomplish with our current supplies. We just have to make it into a successful burn.
Right. Now I have a question about efficiency.
Go ahead.
Times to burn. Is it most efficient to burn this close to the planet, or is it more efficient to adjust our orbit somehow while we're out near the apoapsis?
There is a small extent to which your question is a little loaded. But the reason that is because sometimes efficiency is circumstantial. Are we trying to break into a parking orbit around Kerbin, or are we just trying to make this as survivable a landing as possible?
Survivable a landing is the goal. So
okay. Then, as far as efficiency is concerned, both arguments would work. We can burn way out where we are right now because we'll never get to apoaps again.
True.
Or burning down there will have a pretty significant change. For example, that's 136 and that's at 420. Let's close this maneuver node.
Okay. Want to put an identical one further up?
Yeah.
Okay. So this one.
But you got to delete the first one.
Oh, I guess that would make sense, wouldn't it?
Yep.
We can re-establish that easily enough. So a minus 136 here, which is exactly what we did. Ah, intriguing.
Well, no. At this point, we would want to put positive 136 because we're trying to increase.
Ah. And that puts us out to a periaps of 300,000 kilometers. Or 300 kilometers. Nearly 400. Interesting.
Now,
but
we can shave that down to like an atmospheric clip.
But we're going to have a large apoapsis to get rid of. Because we're actually increasing our apoapsis under these circumstances.
Right, that's because... Right. Activate the flags.
Come on, flag. Silly thing. There we go. Because we can actually manipulate it live. See, now we're... So timing has a really interesting impact on this. But whether or not that's useful, because of course... Because what we've done now... Well, I guess with the atmospheric drag... But our next orbit is actually going to go all the way up to the moon again, which just is insane. You don't want to do that with it, especially if you're dealing with time sense.
Well, there's that. Let's change the camera view right now. Let's rotate the camera. Okay. First of all, it's very possible for that to have been not quite lunar altitude and been deceptive.
Mm-hmm.
But this is a limitation of the trajectories mod because it's not. It's just assuming a baseline entry orientation, an attitude profile.
Oh, okay.
This is like a composite of what would happen if we survived a tumble.
Interesting.
Kinda, sorta. That's not exactly what it is, but you can kind of think of it in those terms. And as long as you have suborbital periaps, you can just keep orbiting ad infinitum, and even if it's only suborbital by 2 meters, you will eventually land because you will eventually bleed off that speed.
Yeah. But of course, if life support is a limiting factor, which in real space programs it definitely is, you don't really want to be sitting in orbit for another 2 weeks and hoping that your batteries don't run out.
Right.
So,
Another good reason to keep our resources panel up because I wanted to make sure that we were getting some sunlight.
Ah, good call. Isn't that weird? Our periaps is down to negative 5,000 now.
Yeah, I'm not really sure what's going on here, but that can't be good in the grand scheme of things. Though I do know that Kerbal Engineer is not updating what's going on with respect to our orbital inputs.
Yeah. All right, so I've kicked us back to the original plan, and I think what we need to do then is adjust our radial, most likely, to pull the periaps up a bit.
Let's make the prograde negative 100.
Okay, 100, and so 5 into there. It's going to be.
Oh no! Give me 50.
All right, 50. That has done almost nothing, hasn't it?
Well, hold on. Negative 100 prograde, positive 50 radial, but our absolute burn is only 111.
Right. Okay. So if I go to 150. Now that's too much. But that puts our periaps at 15 kilometers.
Right.
So, getting there.
Yeah.
But is the radial necessarily the way to go here?
Right.
Or is it a normal issue? Or is it a timing?
Let's make it a radial 100.
Okay. Periaps of 5,000 meters.
Now give me prograde negative 110.
Still 5,000. And we're also overshooting our...
No, I understand.
Yeah.
Let's go prograde negative 85, radial positive 135.
Okay, we're up to... I really should get those tags. There's a 113... but we're still overshooting the amount of fuel we actually have. Now, I believe this ship does have a small amount of monopropellant, but I don't think that's enough to make a huge difference in the...
Well, not only that, we can't use it. We have no RCS jets.
Oh, right. So, oh, yeah, this is the one that had the extra... That's right.
Yep. What we're realizing now is that we can do a lot of things to our orbital energy with our current Delta V budget. But if we wait until here, we're past our 0 hour.
Right. So the only thing we can do
is do it sooner.
Aha. Our apoapsis is rising, but our Delta V budget is staying the same, but we're going to have to cut some fuel out of there to get it down into our 135. So that's a set. So that's nearly 20 kilometers now.
Yep.
And that is...
Let's keep doing what we were doing, but let's make it so that our periaps is between 40 and 60.
Oh, that is going to be... That's the point where we start orbiting, or we have to do an extra orbit. But it's a much lower orbit. Okay. So there we are. That's 40 right there.
Okay. So the projected apoaps, what does that flag tell us?
Projected apoaps is 6 million.
6.5.
6.5, yes. I guess that matters out there.
Factoring in atmospheric drag, it's a judgment call, but that looks like it might be as little as 2 million meters.
Yeah, I think that's... Yeah, it's about 2/3
Probably...
lower, so 2 million is probably a safe estimate. 2.5.
Yeah, 2.5. 2.5. So this is actually a little bit more conservative than we have to be.
Mm-hmm. So we can come in a bit steeper than that, can't we?
A little bit.
So if we go...
Now, here's the problem we run into at this point.
Mm-hmm.
This is more conservative, and it allows us quicker landing, basically, because we spend less time reorbiting.
Right.
But it does require more energy to be taken off by re-entry, which does leave us more vulnerable to the re-entry process.
All right, because we have to go through the atmosphere twice.
Not only that, the first time we're going through, we're coming in at lunar velocity.
Right.
Near lunar velocity minus our absolute delta V burn of 135 as tweaked by the radial vector of 105.
Right.
Some very complex maths become involved. That's why I never became a rocket scientist. I understand what the numbers are doing. I just don't know how to calculate them in my head.
All right. So, what do we need to make this survivable?
My honest opinion right now, and this is real eyeball-y, and if it ends up being crow, it ends up being crow. My honest gut tells me that this or something slightly safer, like backing it off a little bit. Well,
that wasn't backing it off. So back to 40?
I think that's fine for a couple of reasons. One, I think that going out that far is acceptable, particularly because we don't have life support timings to worry about.
Fair enough.
Second of all, this trajectories mod doesn't know how to calculate orientation, which is largely a non-issue in stock aerodynamics, but it does factor some. Third, more importantly, we have more heat shield than just 1,000 units of ablative shield resource.
True, because we're
going to be performing a hardware-assisted braking, yes.
Right. Now, I do see one very significant problem with the... I haven't played vanilla in a long time. Can Kerbal survive if the batteries run out?
Yes.
Okay. So...
with what you're used to with Better Than Starting Manned, the batteries running out only kills them as a function of a loss of life support.
Of course. Okay, cool. So we won't. So that won't be an issue, but yeah, it won't be as big of an issue as I'm accustomed to.
That's correct.
Okay, so I guess we set this as an alarm clock. Yeah, I was just thinking about the amount of time, because by the time once we lose the batteries, because there's no solar panels and stuff on the capsule itself, we're down to just whatever this thing carries, which is a very small amount of juice.
150.
So so that's a consideration, because that will not get you a second orbit around Kerbin. That will not get you back out to here. No, in my experience, that would do you in a life support circumstance.
Now let's F5 real quick.
Okay, 'tis done.
Let's go into the fuel balancer.
Oh yeah, okay.
Monopropellant.
Oh. Okay.
Let's open up the control.
Now where is that? Right here.
Dump. Yep.
Okay. Oh, we got a whole 1 meter per second out of that.
Yep.
But it's gone.
Right.
But that put us,
So what just happened?
Oh, and our cost for our current burn went down a bit because our weight dropped.
And
the ship. yeah, we have a bit more delta V, and our current projected burn is actually got the cost of it's reduced.
Mm-hmm. We're pushing around less spacecraft.
Yeah. Okay. So that gives us a few more.
Nope.
That's not what I wanted to do.
Nope.
What do we need to do?
Go negative.
Anything? Okay.
I like it.
That's dropped our periaps pretty much. I think that's all we're going to be able to squeeze out of it. But that puts us down to a much more reasonable altitude.
Let's orient to the node.
Orient to the node. Oh, yes.
Nav
Yes.
Ball.
Sorry, yeah, my... that would be the same brain I've been using for earlier.
Don't worry about it.
Okay,
I forgot how to brain.
Yeah, I stopped using it for a few weeks, and that was the end of that. Okay, so 1 minute prior to node, alarm set.
Yep.
Okay.
All right.
Time warp time, because we got a few
Time warp time.
We got a few SOI changes to deal with.
Yes, we do.
Here comes the first one right now. Kerbal X Mark II.
How much do we have right now?
Oh, we're definitely at 30.
30?
Just hit it.
Okay.
Yep. Delete on close.
Let's do an outro.
All right. And...
All right. So this was a little bit of a cerebral episode, but we are talking about things to consider in plotting a re-entry, especially on a limited fuel budget.
Mm-hmm. And certainly timing and using the alternate, the not prograde tools makes a huge difference in terms of how you can use your fuel.
Mm-hmm.
This one
this is a much thinner margin of error, 14 meters per second.
Mm-hmm.
So it will be. We're going to be a little bit quicker on the next episode than we were on this one. We were going through the theory and the hows and the whys, and we're going to apply that on both that other craft and this one in the next episode.
Sounds good. Thanks for watching, and we'll see you next time.